Hey guys, welcome back. So today, brought home this Briggs and Stratton home standby generator. Now this is pretty small as far as backup generators go. It's only rated at 7,000 watts and is powered by propane. I'm told by the seller it's about 10 years old. It should run and make power. That said, it's been disconnected from his house for the last couple years. So hopefully it doesn't need much to get it going again. I guess that's what we're going to find out. So let's get this off the trailer. We'll get it inside and take a closer look at what we got. We'll see how this goes. The trailer is actually leaning back, and I was hoping to use that to my advantage when going down the ramp, that it wouldn't be as steep. But I'm not even sure if I can push it to the ramp. I'm pretty excited about this one. I usually don't bring standby generators home. I go on site or I help people remotely. This one I made an exception for. It was fairly local. It looked to be in good shape. Supposedly it works. And the guy was only asking $150. So yeah, this one was a no-brainer. Anyway, before trying to start it, I think I'm going to get all the panels off. I want to look everything over, make sure everything is good. And then we're going to have to do a little bit of work over here because this is meant to be hardwired to a house, and I'm going to be testing it more as a portable generator. So we'll deal with that in a minute. But first, let's get the covers off and take a closer look. So yeah, this is just a tractor engine on the top, and on the bottom is the generator. So this is actually very similar to that Vol-C generator I worked on a little while back. That one had a Tecumseh on top, but basically the same setup. Anyway, I was hoping to see what the horsepower rating was on this. To pull 7,000 watts, you only need about 13 horsepower. I'm suspecting this is closer to 15 or 16, given the type of engine that's in here. Anyway, let's check the oil real quick. Plenty of oil and it's full. So that is a good sign. We'll check the air filter, make sure it has one. And it does. Looks to be clean. So that is good. And there were access panels on the side as well. This is just for changing the oil filter. This one actually has an oil pressure sensor, so that is a nice feature to have on a Briggs generator. And over here, this is access to the oil drain. There is a hose coming out right here, and actually it looks to be zip tied in over there. So that'll allow us to change the oil pretty easily when we get a chance. And then over here is the control panel. Down here is where the battery goes. We have a propane regulator right there. That is the start solenoid. And up here we have a circuit breaker, a fuse, and a few buttons to control the system. So I think what I want to do next is get this panel off because there are no outlets. This is meant to be wired to a house. So I need to rig up something temporary so that we can do some load testing. And I also want to plumb up a gas supply. We'll do both of those things first before getting that battery installed. So things in here look to be pretty straightforward. We have the control panel on the right, and on the left we have a circuit breaker with two wires going into it from the stator, labeled wire 11 and 44. So those are the live wires. We have a neutral right here, and there is a lug in the back for the ground wire. So that seems to be straightforward. We can just run a cord in, connect everything up, and then we'll have an outlet installed to get some power from this machine. Now, I guess there are still a few questions though. We have these two blue wires floating off in space, and we have this connector right here labeled 240 volts. So I'm thinking this is for monitoring grid power, so it knows when to start the generator automatically. And this most likely is some sort of remote monitoring or maybe remote start-stop feature. So I'm going to have to look into that a bit before trying to fire this machine up. For now, I think we have what we need to rig up an external cord so we can access the generator's output. To get the generator connected, I'm just going to use this 10 gauge stranded wire. On one end, I'll get this L14-30 installed, and the other end will be connected directly to the machine. Yeah, hopefully I didn't leave these wires too long because this has to clamp down on the cable, not on the wires. So it's going to be close. May have to recut the wires if they're too long. I think that's going to be good. And then we'll attach this piece here. This is just the strain relief for the cord, which I guess brings me to the next problem. I don't think I have any strain relief for the other end of the cord, so I might have to come up with something for that. Worst case, this is just a test. So as long as I'm careful, I don't think I'll have a problem. And for this other end, I figure, I don't know, about that much. We'll strip back. So the neutral wire is just connected with a wire nut. So this will be fine. The other wires might be an issue because this machine's meant to be hardwired. This should be solid core wire, not stranded. You know, I'm sure this will go into the circuit breaker and could be used for testing, but I have this kit here, which basically will convert stranded wire into solid core-like wire. And the way it works is you just slide that little piece over the strands, and then you crimp down, and that secures it to the wire. So that's what I'm going to do for these other 3 wires. I think that'll make a better connection to test with. So it's easy as that. So we'll just do that 2 more times and we should be ready to get this connected. Actually fits in there pretty well. There's no strain relief, so I mean if I pull the cable hard it should come out, but the inlet here is around a 90 degree and just the tension of the wire is holding it in there pretty well, so I don't think we'll have any issues testing like that. The wire nut I know is everyone's favorite connector. They're actually pretty good if you use them properly. The idea is you want an actual mechanical connection, and then the wire nuts, they are color coded. And based on how many wires you're using and the gauge of the wire determines which wire nut you use. And in this case, we want a red for 2 10 gauge wires. That should be good. Perfect. I've been looking around trying to figure out where these 2 blue wires are supposed to go, and there's not too many clues other than the labeling on the wire. It says E1 and E2, and on the board it says generator. So I took a look online, kind of came up empty, and then I remembered the prior owner did give me some paperwork, and one of those items was the installation manual. And according to this, E1 and E2 from the circuit board run over to the circuit breaker on the load side, which seems a little bit odd. You know, if that's wrong and that's how I do it, I'm going to smoke the board pretty quickly. But I've got a little bit of assurance because after studying these connectors, I can see what looks like to be witness marks of a round screw holding these connectors in place. And if you look at the circuit breaker where I just connected these wires, I think that is a match. So I'm going to connect these wires over to there, and then I think we'll be good to close this up. It just seems wrong connecting the high power to the low power side. That one's good. That should do it. Yeah, it's not the best placement for this wire to come in. It's actually hitting the circuit breaker, and I could probably muscle it closed, but I don't think that's a great idea. So if this ground wire was a little longer, I could actually slide this back quite a bit, and that would solve the problem. So I could redo all the wiring, but in this case, I think I'm just going to extend the ground wire by a few inches, and that should take care of this problem. Just cut that off. Strip it back about 1/4 inch, and then I'll join that to a piece of wire to give me the length I need. Much better. All right, theoretically that's done. I'm going to pull this fuse so I don't forget to do it later. I think with this fuse removed, the system cannot be enabled to start automatically. So when we're ready, we'll put the fuse in and try to start it. Now we need to deal with the fuel supply. This can run on natural gas or liquid propane. Currently, it's set up to run on propane, which is good because that's all I have. Now, in order to do this, I'm just going to use a propane tank from a grill, which granted won't run this for long, and we could have issues with pressure drop, especially as the tank cools as we start pulling propane, but it should be good enough to test with. So to adapt this down, I'm going to use this regulator here. This is good for engines up to 20 horsepower, which this engine is less than that, so we should be good. And on the end, we have a 3/8. I believe this is a flare fitting. So I bought an adapter which will bring this 3/4 NPT down to a 3/8 flare, and then we should be able to plumb everything together and get some fuel to this engine. I know this generator is only 10 years old, but this connection looks pretty rusty. That is tight. I think I need a bigger wrench. Nope, that one's slipping. It's probably way more than I need. But I'd rather have too much. I think that's good. So far, so good. No obvious leaks. Just spray it down with some soapy water and make sure. I think we're good. No leaks. So I'm going to shut the propane off for now while I'm connecting the battery. And I'm going to leave the covers off the generator for testing because I do need to change the oil and clean this up a bit. I'm not going to worry about it yet until we know this thing runs, sounds good, and makes power. And we also have to deal with a cooling issue. This piece right here, it's supposed to go all the way around. And this is what draws cool air in to keep everything at the proper temperature. And with this piece missing, it's going to actually recirculate a lot of warm air. And this is not going to cool the way that it should. You know, ideally it should seal right on the cover and draw the cool air through here, which picks it up on the sides. So yeah, we'll leave that off for now. Let's get the battery connected and try to fire this up. That's a pretty nice feature. We got a heated battery tray, and I believe the engine block has a heater as well. So it'll make starting in the winter quite a bit easier, especially on those coldest days. Now, I don't have the J-hooks to hold the battery down, so that's something we'll have to add to the list. But for now, we don't need it. So I'm just going to use this battery. This is something you would see on a lawn tractor, which should be more than adequate for the task since we have a tractor engine. So let me get some bolts. We'll get this attached, and we'll be ready to go. Just rotating the engine by hand before hitting the electric start. Want to make sure there's no weird noises. You got tons of compression. Yeah, I think we're good. So I've got the breakout cord connected to that L14-30, and we have two items plugged in. On leg 1, we have the kilowatt. In leg 2, we have this light right here, which is turned on and should light up when this machine starts. We also have the propane turned on again, and really all we need to do is make sure the system's off, because when I add this fuse, if it's in auto mode, it's going to see there's no AC, and most likely it's going to try to start the machine. So far, so good. I'm going to turn the circuit breaker on. And at this point, I would assume if I hit the switch to auto, that the engine will start. And if it doesn't, I think if we hit the override button, it should cause the engine to start. So I'm expecting we're going to have an extended crank, since all these lines are filled with air. And I don't see any kind of a purge button. Sometimes the regulator has it on there, but I'm not seeing it in this case. So it's going to crank quite a bit. We might have to reset it. It'll probably throw an error code. So let's flip that switch to auto and see what happens. All right, the breaker's on. Let's set it to auto. It has code 11. And it says AC 60. So yeah, it's not happy about something. And the display just went off. So, all right, that's anticlimactic. Let's shut that back to off. And I'm going to double check the manual, see what those codes mean. I checked the manuals. They weren't a whole lot of use as far as what AC 60 was. After Googling it though, it seems like it was just the system board telling me that it was set up for 60 Hertz. So there's no issue there. If it was a fault, it would start with FC. The code 11, still not sure what that is, but let's try this again. I'm going to set it back to auto, and this time I'm going to hold the manual override button down. That should force the engine to crank and hopefully start. Well, the good news is it started without too much effort. The engine sounded good, and it makes power, or at least I thought. I nearly had a heart attack when I went to check the kilowatt and saw that it was dark, and yet it was plugged in. So I shut the machine down, pulled the fuse. I didn't want to cook anything. And on closer inspection, I think it's user error. That plug for the kilowatt, not all the way in. So let's try this again. That's more like it. We had output on leg 1 and leg 2, and according to the kilowatt, we were close to 120 volts, 61.7 hertz. Now, I did shut things down a little bit sooner than planned because I saw a bunch of junk blowing out from under this engine cover. So we have a mouse, or had a mouse, living right there. And without cleaning this stuff off, it's going to cause the engine to overheat. So I'm going to disconnect the propane and the battery. We'll get the engine cover off and clean up the mess that Mickey made. Although I didn't have the kilowatt fully plugged in, I thought I would double check the wiring to see where things are at. Now, a stator like this, I haven't tested one like it before. Usually I get readings on stators between 0.4 and 0.3 ohms. So I plugged in the multimeter to measure the ohms, and we're seeing some erratic readings. Right now we're on one of the legs. We're at about 20 ohms, which is way too high. And if I click the circuit breaker off and then back on, we now have 160 ohms. And sometimes I get in the thousands or the millions. Like right now, for example, we're at 11 million ohms, and that circuit breaker's on. With a reading like that, it's no wonder we weren't getting power. So let's turn the breaker off, back on. Now we actually have a good reading, 0.3. So, yeah, I think this breaker should be replaced. I've already clicked it on and off a couple hundred times, and it's no better. It's very erratic. We'll just try it one more time. Now it's at 2.5, which isn't terrible compared to the millions of ohms that we sometimes get. But yeah, right now the circuit breaker's on, and you see we're in the millions of ohms, and there was quite a delay to showing even that, because this can only measure up to about 20 million ohms. So right now, that breaker's on, and we're at 14 million ohms. That's an issue. So, yeah, we'll place an order. We'll get a new circuit breaker. We'll get the missing parts down here. We'll get the oil filter and anything else we need. And in the meantime, we'll evict the critter. I'm just going to pull this off since we have a new one on the way. And I'm going to clean everything before getting this cover off. We get these bolts out. There's 2 on the front, 2 on the back. And I'm pretty sure there's another one under there. So we'll pull the air filter out and just double check. I'll get that out of the way. Filter's in good shape. It seems like we're mostly free. It is hung up over here. There's no bolts though. I think it's just the intake tube. So I'm hoping it's just an O-ring that we can pull off. Not sure. There we go. There's really not much in here. I think most of it got blown out. I do see some evidence of a critter and some little nuts or something down there, but most of it's gone. So I'm just going to take a second, vacuum out and blow out what's left, and we should be good to put this back together. It's been a couple weeks, and the parts I've been waiting for are finally here, starting with, I would say, the most important part, which is the circuit breaker. Originally, I ordered this using the Briggs part number, and it was back ordered, so I ended up pulling the panel out again and found the maker's name and their part number, so I was able to locate the correct part using other channels. So that will get installed. I also got the new seal for the top of the engine and was kind of surprised at what I got, because this piece here, it is exactly this length. It's not a full circle. And that I don't understand, because the parts diagram shows this going completely around the top to seal it up, to pull the fresh, cool air from the outside. And, that's really the only thing that makes sense to me. So I'm not sure why we only had one in there and we only got sent one, half of one. So unless someone can tell me otherwise, I'm going to put them both on and hopefully seal it up a bit better so we can actually pull the air from outside of the machine instead of recirculating that warm air. So we'll get those parts on. I want to get it started again, run it a little bit longer, and then we will change the oil with the new oil filter. Not even a half seal. We're a little bit short, but still, I think it's going to be a lot better than half a seal. I did test this one. It comes in consistently at about 0.1 ohms, so it's a very good connection. So I did double check the circuit breaker before installing it, but just wanted to show you guys the difference between a good circuit breaker and a bad one. So I'm probed into one of the legs, and right now we're at 0.3, 0.2 ohms. And if I cycle it off and back on, we get consistent results. And that's how it should be. Then if I move over to one of the other legs, it should be very similar. 0.3. That seems good. And turning the switch off and back on makes no difference. So the new circuit breaker, it is working properly. And the old one, actually I thought for a second may have been good, because when I went to uninstall it, the wires coming from the stator that go into these terminals, one of the screws was pretty loose. So that could definitely cause an erratic reading like we were seeing. But thankfully that's not the case, because right now this is turned on, and if I probe it, we should see something similar to the new circuit breaker, around 0.2, 0.3. And in this case, we're getting 5 million ohms and rising. So yeah, that is no good. And on the other side, I checked this earlier, we were actually getting a pretty good reading this time, 0.1. So yeah, definitely not a good circuit breaker. Yeah, I've got everything connected and I'm ready to go here. I've got each light plugged into different legs. They are turned on, so we should see them turn on if everything is working properly. Now, there is air in the line again, so it's going to crank probably an extended period before it purges that all out and it gets running. So once running, I'm just going to let it run for a couple minutes, long enough to warm up that oil a bit so that we can get it changed out. There we go. So while we're waiting for that oil to drain out, now's probably a good time just to drill out these rivets and take a look inside. You know, I don't think we're going to see anything catastrophic here. Most likely we're just dealing with a bit of corrosion. Yeah, it's not exactly going as planned here. I've already broken a corner off. And the issue is when I try to drill these rivets out, they just spin. So I can't really get a bite on them to drill them out. And they are recessed, so cutting them off isn't really going to work either. Yeah. That works. Making progress, but not the way I had imagined. One more to go. Man, this thing's a little delicate. But we got the rivet out. So let's see what we have. So this side, the one that had the sticker on it, was the one that was actually measuring the high resistance the last time we tested it in the 13 or actually 14 million ohm range. So right now it's on. And if we switch it off, let's see what opens up here. I wouldn't say it came apart very well. You know, I was thinking just drill out the 4 rivets, the whole thing comes apart. And it didn't quite work out that way. The rivets weren't exactly tight. They were just spinning in there. And once I drilled them out, you know, I hammered them the rest of the way. And this thing just completely fell apart. The plastic is very, I wouldn't even call it brittle. It just feels like clay. It's hard to explain, but not a lot of strength to it. So it just kind of disintegrated. Anyway, this was the one that was just testing at kind of in the 14 million ohm range. And you can see why. If you look down here, you can see some powder. That is corrosion that has flaked off this contact and that contact. So that is the only reason why this was testing bad. Just that corrosion was preventing a good connection. It was high resistance. And if you look on the other half of the circuit breaker, this one was testing well last time we checked, and there's no corrosion down there. And if you look at the contacts, they're also fairly clean. So yeah, this side wasn't too bad. You know, regardless, this is never going back together, which thankfully I have a new one. Anyway, let's get back to that oil. The oil looks pretty good. No shiny bits in there. So we'll just get this drain tightened back up and then swap out that oil filter. It looks like this is going to make quite a mess getting this filter out of here. I checked the manual. There's supposed to be a specialized tray to catch the oil and bring it out. You know, of course, that wasn't included with this machine. So I'm going to use a Forma funnel to hopefully direct the oil out and into the oil tray. It's tight. Oh. Wow. That is on there. No. It won't come off. Wonder if it's ever been off. Man, that was tight. You should only tighten these by hand, and this thing was torqued down really tight. Put just a bit of oil in here, because it's a sideways mount. A lot of it's going to spill out. I think it's still better to have it wet with something. So I just put in 1.3 liters. The manual calls for about 1.35. So, actually it looks like we're a little over full, but the filter also hasn't been filled up. So I'm just going to crank it. We'll let it sit for a minute and double check the oil level. Perfect. Right to the full mark. Well, I think we're pretty much ready to go. This machine, it is rated at 7,000 watts, so that's what we're going to put to the test and see if it can do it. But we do have to keep in mind, we're running off a pretty small tank. And even though the tank is full, it's not going to make much of a difference. As this machine runs, the tank actually cools and the pressure drops. So if we have any problems with the engine, we might have to shut things down and regroup. Anyway, the plan is just to get the engine started, and while it's warming up, we'll double check the outputs. But this time, not with the kilowatt. I don't have access to the 120 volt legs, but that's okay. We have pretty much everything we need here in the load bank. We have volts, amps, and hertz, and we also have the amp probe to measure the total harmonic distortion. And this one I find of great interest, especially on a home backup machine like this. Portable generators, they come in at about 20% THD under full load, and that's not great for electronics. Ideally, it would be 5% or less. And being this is a standby machine connected right to the house, I'm hoping it's a little bit less than 20%. Anyway, the last thing we have here is the oscilloscope. We can use that to see the sine wave, and that is actually probed into the 240 using the binding posts, and isn't the safest connection I've ever done. So I'm going to have to keep that in mind when operating the controls over here. I don't want to accidentally bump that. So let's get the engine started and put it to the test. So no issues at all getting this generator started. It's running nice and smooth, and without a load, voltage is perfect at 240 volts. And the engine speed, it's a little bit higher than I would like. I would say it's about 62.5 Hertz, but that is pretty typical of where manufacturers set their machines without a load. The THD, not great. It's at about 7%, but it is fluctuating. Maybe 6.8, and the sine wave, not great, but hopefully that'll clean up under load. So let's put on a 3,000 watt load, starting with 2,000 watts. No issues at all. The voltage is steady, and so is the engine speed. Now we're at 3,000 watts. Yeah, things are looking pretty good. We're holding at about 61 Hertz, but the THD did jump quite a bit. We're at 17.1%, and the sine wave, although not as jagged, is still a little bit deformed. So let's give this a few minutes, and then we'll go for the max of 7,000 watts. All right, it's been a few minutes and no issues at all, and I'm pretty impressed actually with this machine. It is fairly quiet for a traditional generator, but I guess that's what you'd expect for something that you connect to your house. Anyway, let's bring up the load. I'm going to swap 1,000 for a 2. So now we're at 4,000 watts. Everything's holding fine. Let's try another 2,000. Now we're at 6,000 watts, 6,500. 7,000 watts, so no issues at all. THD is at 21.2%, and the sine wave still distorted, but I've seen quite a bit worse. So we'll give this a few minutes, and then I might go for an overload and just see how much this can handle. So no issues at its rated load. So I'm going to swap this 1,000 for that 1,000. So now we're back at 7,000 watts. Let's try 7,500. It's doing it. How about 8,000? Yeah, it's doing 8,000 as well. So let's keep going. So we're back to 8,000. How about 8,500? Yep. 9,000. It's doing it. It's holding actually at about 57.5 Hertz, so that's pretty impressive. I guess we can keep going. So we're back at 9,000. How about 9,500? Yep. 10,000. No, I'm not going to try it. The engine speed's unstable, but we're at 9,500 watts on a machine that's only rated for 7,000, so that is really impressive. So we'll give this a few minutes for the load bank to cool down, as well as the engine, and we'll shut it down. But I think I am going to make a small adjustment. You can see we're flirting with 63 Hertz, which isn't great. So I think to do that, likely we're going to have to open it up. So yeah, let's give it a second to cool down. We'll shut it down and just bring that speed down just a bit. I've got to say, I am really impressed with this machine. Not so much on the power quality side, it was just average, but on the horsepower side, this did a fantastic job. To produce 7,000 watts, you need 14 horsepower, and most manufacturers size the engine exactly to meet the continuous rated load. And in this case, clearly this engine is oversized because we just pulled 9,500 watts, which would suggest this engine was producing about 19 to 20 horsepower. So yeah, pretty impressive. As far as the engine speed goes, I think I'm going to leave good enough alone. I thought we were closer to 63 Hertz, but we were actually pretty close to 62 Hertz. So that is within spec, and Briggs usually sets their machines between 62 and 63. So, the fact that we're on the low side of 62, that is close enough. Anyway, at the end of the day, this didn't need a whole lot. I think the prior owner really just wanted to get rid of it. Really, the biggest issue I found was the circuit breaker and the critter, and of course the missing seal. But even that I'm kind of questioning, because I just saw a very similar model up for sale on Facebook, and the seller had the cover off and they only had half a seal as well. So my best guess is that Briggs wanted to recirculate some of that warm air on purpose, most likely for cold weather operation. So I hope this video helps someone. Thanks for watching.